ultimately implicit differentiation is really some form or a form of the chain rule, believe it or not. That's why we have to teach you the chain rule before we start implicit differentiation. There's some general guidelines or steps to follow anytime you're asked to use implicit differentiation to find dy dx. First of all, you differentiate both sides of the equation with respect to x, and I'm going to show you have to write that step. On a free response on the AP exam, you cannot just jump in and start doing the derivative without explicitly showing that you're taking the derivative with respect to x, or when we do related rates, it will be with respect to t instead. So it really matters what you write there. Then once you've done that, we're going to collect all the dy dx terms on one side of the equation and move everything else to the other side of the equation. I know in the book it says move all the dy dx terms to the left and then everything else to the right. It doesn't really matter. You can just pick one side to collect everything, all the dy dx's, and then move everything else out of the way. And then finally, you factor dy dx out, and of the left side of the equation or the right side. I should say here, this could also, or right. Whichever side it ends up. The key is that you factor it out. And then we solve for dy dx. So let's try a problem. So number one, first you have to show that you're taking the derivative with respect to x on both sides. So you need to write d dx of y cubed minus y squared minus 7y minus x squared is equal to d dx of negative 16. Listen, it is an operation just like sine of x is an operation. So please, please do not write this on this side. That would be completely wrong. It has to be in the front. You can't shortcut this. You're going to have to write it as a separate step. I know it's a pain to have to rewrite stuff, but in this case, you're going to have to do it because you're indicating what variable you're taking the derivative of. Then we're going to go ahead and do each part. So 3y squared. That's the derivative using the power rule. And then using the chain rule, I get dy dx. Minus 2y. Again, using the chain rule, I get dy dx. Minus 7, again, using the chain rule, dy dx. Minus 2x, but in this case, using the chain rule, I would get dx over dx, which is just 1. I'm not going to write that. On the other side of the equal sign, I'm taking the derivative of a constant, which is 0. One of the most common mistakes here, by the way, is to write negative 16. For some reason, people don't set that equal to 0. Now the key is to every term that has dy dx, we're going to either leave to the left or to the right. It doesn't really matter. In this case, they're already on the left-hand side. So dy dx minus 2y dy dx minus 7 dy dx. This step you couldn't skip because some people can do that in your head. They know that they're going to factor out the dy dx. So now every term that has dy dx, I'm factoring that out. So I'm left with 3y squared minus 2y minus 7 is equal to 2x. And then divide both sides by that whole trinomial there. So that gives me dy dx is equal to 2x over 3y squared minus 2y minus 7. Now I sketched it in case you wanted to know what the function, or this is not a function, I mean the relation looks like. So, and we're going to use this problem down underneath again, so we're going to refer back to this. Now I want you to pause the video and try B, and again, I just sketched it so you would know what that function, or not, I keep saying function, what that relation would look like. So please press pause and then do part B. This is what I'm getting for part B. The key here is where most people mess up on this one is on the right-hand side of the equation, you have to use the product rule. All of this, you have to remember to use the product rule there. That's most likely the most common mistake that I see on that one. Whereas on part A, it's not taken when you take the derivative of a constant, writing it equal to 0. All right, so now continuing on, I'm just going to use example 2A. So we're exploring example 2A